So what I'm now going to ask the panel to do is something that's very risky as a moderator. You don't normally ask panelists to do this, but I'm going to take the risk. I'm going to ask each panelist to introduce themselves, which is risky because it could take up the whole of the panel if we're not careful. They could speak for far too long. What I'm going to do is ask each person, starting from Ari here right the way down, to say their name, their company, job title, and a little bit about what their role is in 6G. But in only one sentence, right? One sentence each, not a paragraph, not 10 minutes, one sentence. So I'll start here and then we'll work down the panel.
Thanks, Jan. So Ari Kynäslahti from Nokia, CTO of Mobile Networks. I'm in a search of a golden band for 6G. So we need to find a good macro band for 6G.
Thank you. Great. One sentence. You've set the bar here.
Okay.
My name is Luciana Camargas. I work for the GSMA. I'm head of Spectrum. So for me, what I would like to say is that we have to plan. It might feel that it takes 6G is a long way away. We need to plan 10 to 15 years in advance. So this conversation is really timely.
I'm Marvin Chen from Huawei Relax product line. I'm a CSO of mainly responsible for strategy and developer engagement. So briefly, regarding the sentence, I would like to we would like to work with the industry to create amazing 6G, either for technology, either for use cases.
Good morning, everyone. Christina Data. I'm the regulator in the room from Ofcom, the regulator in the UK, and I'm the director of Spectrum Policy and Analysis. And my thought on 6G is, as Ian actually said, is not only spectrum, it's spectrum, densification, and technology. How can we work along those three axes to actually deliver connectivity for all?
Hello, my name is Claes Nykander. I work for Telia, heading up the office of Chief Operating Officer, and thereby responsible for acquiring spectrum for Telia Group. And my one-liner would be that I think that we need a one harmonized band between 7 and 12 gigahertz for the whole world in order to get the scale out of 6G.
Thank you very much. So I'm going to start the panel with a very contentious question. I've been at various events, panels already in the last few days in Barcelona, and there is some cynicism, I think, in parts of the industry about, whether we need all the spectrum we have in the mobile industry. What do we need? What are the use cases of 6G that are going to drive spectrum? I don't know who wants to jump in on that, but what are the use cases that mean we need more spectrum than we already have?
I can start. So let me start with the boring one, which is the fixed wireless access. So many of our customers basically doubled their frequency assets with the 5G, getting 100 megahertz of TDD band or more, C-band 3.5 or 2.6 gigahertz. That's plenty. And then, because there is so much, many of our customers are using it also for the fixed wireless access. When you start to use it for fixed wireless access, anything will be eaten, or everything will be eaten. So more bands with 6G will be needed already for the fixed wireless access. But then also, if you look at XR, so we need to do XR so that it works all over the network, 95 percentile. The kind of downlink, uplink data rates need to be 25 megabit per second all the time, 95 percentile. And it sounds easy, but it's not. When you really want to have it all the time across the network, we need more spectrum for that one as well. Plus then 6G will introduce completely new use cases like sensing, where we first time will use the radio both listening and talking at the same time as a radar. So for that one, probably the sub-terahertz, something between 90 and 240 gigahertz would be good. But really this golden band of 7 to, let's say, 15 gigahertz, that's the area where we will then build the new macro 6G coverage layer.
So use cases for 6G.
So instead of predict what are the new use cases for safety, I want to see a story. My daughter is now in high school. He's a fan of cloud gaming. But right now in China, a lot of some very popular cloud gaming games based on cloud services. But regarding the latency and also certain subscriber in certain area, is with 5G network still have certain limitation. So that's why if you want to log on to this cloud gaming, you have to wait for example, even 30 minutes, because they have to limit the subscribers for this cloud gaming services. But it's very interesting. So young guys, especially young guys, they love this cloud-based gaming very much. So I think instead of to foresee what's the future of 6G after maybe 10 years later, so let's start from cloud gaming to make it happen, to fully fulfill requirement of the young guys, to let them join in this cloud-based gaming services. So I start from our step to the future.
So we have XR. I think we have the consistency of the experience required. We have cloud gaming. We have sensing. And we have fixed wireless. Other use cases the panel believes are important in the 6G context?
I think you pretty much got it there. I think there will be a huge demand for 8K, 16K video streaming as well. I think we have seen some cases here interesting around metaverse, extended, you mentioned already extended virtual reality and so on. So those I think will be driving the capacity and the need.
So video streaming, high quality video streaming, that is actually quite interesting. It's quite challenging even on today's networks if you want to do live video streaming where everyone is very sensitive to delays. Because even small delays in a live sports stream mean you miss the goal. I remember in the World Cup, I was at a party. The people I was there with were not football fans. I was watching on my phone. I could literally hear people cheering before I saw a free kick taken, which meant I knew it was gone in. So there's that. It's not just pre-rendered video on demand. If you think about live streaming, that's a much more challenging use case. Other observations on use cases? What about beyond consumer? I mean,
enterprise, definitely, yeah. I mean, there is so much getting rid of the cables in factories, inside cars as well, okay, and ports, mines. There also quite often the use case benefits from the short latency, and we can definitely improve the latency with 6G.
Yeah. Yes, I wanted to sort of react a little bit to the use cases that have been mentioned, because a lot of these use cases will need capacity. A lot of let aside the sensing, where yes, it's a very, very different proposition, maybe a niche proposition, and you need and the terahertz might be the right territory. But in reality, it's a lot of capacity growth in capacity that you need to meet this excessive demand from consumers and from businesses. And in a way, as a regulator, I think I need to be the challenging voice in the room that says there is a lot of millimeter wave spectrum that will be made available. We follow the challenges that we totally appreciate millimeter wave has got, but at the same time, and I wanted to use this word in my intro, but I thought I needed a little bit more than a sentence. There is a lot of users already in the 7 to 15 gigahertz that is being targeted by vendors, and therefore sharing, and that's the word, sharing is going to be very important. Sharing will become more critical if we need to give access to this additional spectrum. So understanding the use case is a lot better, and where the capacity is needed for us as regulator will become increasingly important when we're actually trying to enable very different uses in society that deliver benefits.
Are you thinking about shared license models like the CBRS model in the US, or are you thinking about some other kind of sharing?
It could be many types of sharing. It could be geographic, it could be dynamic, it could be anything. But given the users that already exist in this band, a lot of them military users as well, we will need to be a little bit more creative if we need to provide access to these bands.
If I can add to the
Sure,
discussion,
go.
I'm head of Spectrum. I don't think use case is my particular area. I will leave to the technology people to talk about what future will come. But if there is one thing that I know, and one thing that my experience tells me, is that there is always additional need for spectrum. If you look at how you used your phone in 2G, 3G, 4G, 5G, we use a lot more. I can't imagine living in a 3G world right now where I can't even do a bank transfer, let alone all the things I do with my phone today. So I can only assume, as in the spectrum world, there are going to be use cases and more spectrum will be needed. And in order for that spectrum to be available when it's needed in 10 years' time, in 15 years' time, we need to start thinking about where it comes from, how we share, how we accommodate. So we need to start planning. And I think, to me, that's the crucial part of it.
Yeah.
What about the learnings from 5G on spectrum availability and licensing? What are the learnings we've got from that? I mean, although we are 4 years in many countries, there is still licensed spectrum for 5G that hasn't even been launched commercially yet, and there are a few auctions still ongoing. So what are the lessons from 5G that we can feed into how we approach spectrum in the 6G era?
Start early and do it global. So we have the World Radio Conference in...
Start now.
Now, yeah, right now. And especially Dubai, November this year, we will have the World Radio Conference 23, where we start the work, and then World Radio Conference 27 will stamp that these are the frequencies, so all the work will happen in between. So this is the time, and let's do it global. So if we look at globally, and I agree, there are challenges on this, let's say, 6G golden band, 7 to 15 gigahertz, even extended to 24 gigahertz in some cases. Yeah, there are challenges, but we also have time. And we can use the new technologies like the sharing one way or another. But key thing is to start early and do it global.
Klaus?
Yes, I see that for 5G we had the C-band quite available as the macro band that will take the sort of bulk of the traffic. We also had the millimeter band, hasn't really taken off yet, but I see that as an expansion band. For instance, when we see FWA and other sort of traffics to take off, to sort of offload C-band. Then importantly, we also had 700 to get the wide area coverage. So I think a lesson learned for me is to have a sort of a portfolio of spectrum for the things we are up to achieve. To have a macro band, preferably 6, 7 to 12, 13, 14, comparing to C-band. And then of course expansion bands could be the sub-Tera. And then I have never given up the hope to have more sub 1 gigahertz spectrum as well.
Yeah, yeah, the low band is needed too.
The UHF type bands.
Yeah.
Mm?
Yes, and if I may add, I think that was one of the success of 5G, as you clearly said, Claire. Having those three different ranges, a lot of spectrum, globally harmonized, particularly on the C-band, we've seen the deployment. My call to action again is the millimeter wave was the pioneer band for 5G, where everybody was seeing a lot of potential. It's coming in a lot of countries. It can address a lot of capacity constraints. We would like to see it more used. So a little bit potentially of a disappointment worldwide, apart from the US, where they launched it because that's what they had. We would like to see it a little bit more adopted throughout the world, because it was the new thing for 5G. So again, this is why possibly we've done some work on terahertz, etc. A little bit more skeptical, because we know that sometimes it is really, really difficult. So you look at the dream of going higher up in frequencies, but then you hit the challenges of the ground. So how can we address these challenges? And I'm going back to the other word that I use in my line, densification. In some cases, you might need densification on top of additional spectrum.
You remind me, I remember being at another event a year or two ago and was chatting with someone afterwards about spectrum, and he said, you know, 30 years ago, above 1 gigahertz was high frequency.
Exactly. Yes.
Which is true. You know, if you're in the 1G to 2G era, you know, that was high frequency. I think the initial 2G services were 900 megahertz, then there was the 1800 megahertz bands added on, and that was considered high frequency. And then 4G went to 2 to 3, 5G 3 to 6 millimeter wave, and now we're pushing up further with 6G.
Yes.
So,
If you asked the question about what lessons we learned with 4G and 5G. And I think there's been mention on the 3.5 gigahertz mention on the stage. If we look at what happened with 3.5, we in the 5G era were quite lucky because 3.5 actually started being harmonized in 2007. I've done loads of WRCs, and I started discussing 3.5 gigahertz in 2004. So the reason, because it didn't take off for 4G as people thought at the time, because there were other 4G bands available. When 5G came, 3.5 gigahertz was there, already almost globally harmonized. Yeah. But for 6G, I don't see any extra capacity in mid-bands, and there's going to be some need in mid-bands that we would be lucky that is left over from 5G. And I think that's something that we need to seriously consider. With respect to millimeter wave, we do believe it's coming. We do believe it's a timely fashion. The networks need to provide the basic, which is the mid-bands, and then they will build the millimeter wave on top of that. In my ward, in the regulatory ward, we say it takes 10 years from harmonization within the ITU to implementation. 92 identification, 3G came in 2001. 2000 identification, 4G came in the 2010s. The millimeter wave was identified in 19. I don't think they're late. I think they're exactly on time where the technology matures. But then we need to think ahead for 6G.
Of course, I mean, we haven't got anyone from the Americas on this panel, I don't think, anyone based there. I mean, they may have a different view on the kind of sort of 3 to 4 gigahertz bands on the availability, because those are only just rolling out now. I think in the States, I think they've had the second tranche of their C-band available for deployment. The third tranche, I think, arrives next year. I think Canada's been similarly challenged on C-band. I think Brazil got that, I think, last summer.
I'm Brazilian. Am I qualified to speak about that?
Okay.
I'm based in the UK.
You're based in Europe, though.
but I follow.
But I think what that means is I mean, it shows highlights. You know, although as you said, it worked quite well, there are still parts of the world where there have been challenges on those bands.
But in the Americas, I'm sorry, if I just finish that. In the Americas, the challenge was quite different, because the US and Canada have a problem that was radars in the 3.5 gigahertz, which Latin America didn't have. So what we're seeing in Latin America now is actually the band, the lower 3.5 is actually available because they never had the radars. And the US took a long time to clear the radars out of the band. And of course, we all know the sharing with the FSS. I will stop
Marvin,
there.
do you want to jump in on this topic about lessons from 5G?
Yeah, so to answer this question, I would like to see if we talk about what we can learn from 5G spectrum planning and management. So I think it's somehow like a country-based and scenario-based. So right now, worldwide, they have around 90 countries already allocate spectrum to 5G. More than 80% of them is, of course, stuff from 5G deployment from the new band, the C band, the 3.5. But some countries are now talking about the second second band, stuff, for example, the 2.6 TDD spectrum, F8 is available, and even 2.3 TDD. But still, some countries, they are C-band or 2.6, 2.3 is not available. So they are starting their 5G deployment stuff from, for example, 2.1. And even sub 1 gigahertz, 700, 800, 900. And even for the countries, they have C-band deployed already, but for large scale, citywide, nationwide, but they're still deploying the low band for the rural coverage or for indoor coverage. So I think it's mainly what we can learn is, yes, we have mainstream of the industry, the new band as a primary band, but we still, the industry, how to think about some specified cases. So, for example, the terminals and also the networks, we have to think about the certain solutions to support this kind of special requirement based on their situation. So I think these kind of things might be happened even in 6G. So maybe we have a primary band in 6G, but still we in different countries we have different situation.
Yeah, I mean, I think one of the things that we see on the open signal side on millimeter wave is there were early deployments in North America, a bit in Korea, Japan, and a few other places, and there's cynicism, I think, globally about millimeter wave, but we have to remember we've had 2 or 3 years where people haven't been congregating in big crowds in urban centers. Those locations haven't had the same pressure of users hitting them at peak times that would have happened before COVID, and I think hopefully will happen now. And so that need for capacity has probably been slightly put on ice for a bit because we've had C-band stuff arriving that's been good enough in capacity for those centers for the kind of patterns of usage we've seen in the last 2 or 3 years. But that isn't necessarily sufficient for the future as everyone returns to more usual behaviors of spending 100,000 people in a football stadium or in a conference center in Barcelona, where you really need all the capacity you can get to support all the video streaming and pictures and things that you guys are doing of the panel as we're speaking. So moving on a little bit, what are the key bands that we think are important for 6G, and why are they so important? Why are those bands the bands that are important for 6G? And I'll throw that to, I think, Christina looking.
Can I start?
Yeah.
Let's start from the existing bands. Yes. Let's not forget that there is a lot of spectrum that will be refarmed. So I want to just put it there. Then we can explore everything that is being explored. But we have seen in 5G already quite a lot of refarming in the UK. So let's not ignore the fact of all of that spectrum being available. And I'm becoming a broken record here, and the millimeter wave as well. But I know, and I can comment later, but I wanted to put that on the table.
Are you thinking of refarming from 2G to 3G, or are you thinking of refarming 4G and 5G bands?
I think that will be a time in which you refarm from 4G to 6G, yes.
I'm very happy to agree with the regulator. I work with government affairs. I don't think there is such a thing as 5G spectrum or 6G spectrum. What happens is that spectrum becomes available when certain technology is thriving, but what we planned as 4G spectrum became 5G spectrum. In some countries, for example, 2.6 gigahertz was started as 4G, but if you get a license now, you don't implement 4G, you implement 5G. And the technologies mature in life, and the operators will reform, and they will evolve in technology. So when we do our spectrum needs studies at the GSMA, we consider that all bands, all IMT bands are used for that technology. So it's a best case scenario. You already migrated everything on top of everything else. Do you still need more spectrum? And the answer to us is yes. Yeah. So considering all the IMT bands already for 5G, we are looking at the GSMA 2 ranges. 7 to 15 gigahertz, potentially 24. And I know it's challenging, but if people want to use more their phones and the use cases are there, we need to be able to cater for that. And terahertz. Might be different regulatory situations in those 2 bands, but we are. We also need to look at low band, and that's a really complicated conversation with the broadcasters, but it is something that it's always challenging, but it needs to be looked at.
I couldn't agree more.
Yeah, I do agree as well, and just want to underline that the portfolio spectrum as we had for 5G to also see to, and I really think the sort of, I wouldn't call it an anchor band, but the starting band, the macro band, somewhere between 7 and 12, 13, 14. And that because technology-wise it is suitable, and then also in terms of the grid that we have, we can build on the sites to a large extent now we have for C-band to explore that further for 6G. So for all good reasons, I think we need to start there. I do agree that we need to reform as well and utilize what we have, but nonetheless for the capacity demand and the use case demand, I think we need this macro band also for 6G.
But, I mean, if you think about the radio generations, I guess, the radio technology generations from 2G to 3G, 3G was more efficient in its use of X amount of megahertz. 3G to 4G, when we went to OFDM, again, massively more efficient, could support more data, more users in the same amount of spectrum. 4G to 5G, not that great an improvement in efficiency. Are we going to see a big jump in efficiency with 6G? If we're not, is refarming actually going to help us very much?
Yeah, maybe I start on this one. So if I look at the kind of cell capacity, we see 20 times improvement from 5G to 6G. So like if the carrier bandwidth goes from 100 meg to like 400 megahertz, that's a factor of 4. And then on the receiver side, going to higher order MIMO, and we can do something like 5 times better. So 4 times 5, 20. So that's the kind of spectral efficiency improvement, the capacity improvement between the technologies 5G and 6G.
25, that's way better than 4G to 5G. Marvin, do you want to jump in on this?
Yeah, yes. I agree, but I'm not totally agree with Ian, with the moderator. It's your, so if you look at we are talking about the industry, we are talking about the 10 times capacity gain compared to 4G, right? So we can see 4 to 5 times among these 10 times is the contribution of spectrum, right? We start the 5G deployment. The primary network start from C-band, 5 times more bands. But we have to think about another 2 to 3 times come from technology evolution. Yes, we are still using the OFDM as a basic radio interface, but technology is keep moving. So it's too technical, but we have to see the industry is not introduce some new technology, for example, the massive MIMO to the industry to enhance the spectrum efficiency to 2 or 3 times. So we can foresee in the coming, in 6G era, also the industry is now working on similar direction to further enhance the spectrum efficiency. Even they are using the same spectrum, but also, one more thing I want to say is, if I look back to think about the C-band, we start the identification of this band from could be the years as I know is 2007. So right now it's 16 years past. So this band is our primary band for 5G deployment, and that's why we have 10 times performance gain. It takes us 16 times to clear this band, to make the ecosystem mature enough, and to find a new solution to maximum potential of this band, right? But when we talk about next generation technology, yes, we needed to introduce some new technology evolution, but we still have to think about to make the spectrum ready as early as possible. So if we look at on the table how many candidate bands is available or could be one of the options. So I think the industry is talking about, for example, upper 6 gigahertz. Hopefully we will be identified during VAC 23, Dubai, November. But could be all other, for example, 7 to 15 or 7 to 24. But personally, I think if we learn from the experience of 5G era, we have a band as early as possible to make it ready and to just leave time for the regulators to clear the spectrum is very important.
So I think we've got some clear use cases of tremendously growing data consumption on fixed wireless, the need with XR to have that super consistency, ultra reliable consistency. We've got increasing video quality. We've got a massive improvement, it sounds like, in the efficiency of 6G, which means there are good reasons to deploy 6G. But if we look at those new spectrum bands particularly, what are the new licensing models we should be looking at to get those new bands into use so we see these benefits fast? What are the different ways of licensing that we should be thinking about?
Yes, I'm going to take that one, since we will be one of a regulator that will have that conundrum to sort. So I want to give an example that is what we had proposed, for example, in millimeter wave. And I know it is different, but we have proposed something slightly innovative compared to previous model, where we've been proposing to award in cities. So we understand that there is a value behind providing that certainty of deployment in a given area. But we think, in the case of millimeter wave, but this is just an example of where the thinking is going, let's do in cities, and we've actually identified quite a number of cities that will be awarded altogether. But then in other area, let's allow a more shared access, first come, first served kind of approach, so that other players can also benefit, but at the same time you give to that element of public network the certainty that they have on deployment. That may be very specific because we're looking at the characteristic of a spectrum that doesn't travel very far, and therefore it's suited potentially to that type of model. But at the same time, when as the UK, we published our document on the future approach to mobile market and spectrum, we also said that the capacity that may be needed may be localized. So how can we look at local? And local doesn't need to be a city. It can be anything, yes, so I don't want to put boundaries to that, but it's trying to make sure that the spectrum is available where the spectrum is needed.
So
and this is why the use cases for us are also very important.
Is that local just for the very high frequency bands, or could you see that for the
think
lower
we're
bands too?
I think we're seeing a potential to sort of, because if we want to do sharing, we may need to think differently on how we authorize the spectrum in this given band. And different type of model might fit best what in reality the MNO want to deploy and need to do to meet the capacity demand of consumers and businesses.
I'm going to go slightly on a different path. We're very happy to investigate new models, but we do believe that it's very different because of the characteristics. It's very different when you're talking about mid-bands and when you're talking about millimeter wave. We're actually about to publish a study on spectrum set-asides and the consequence that has in the market, and I can share with those interested. But the issue that I see there is that it becomes a waste of spectrum. Because if it's a mid-band spectrum and you're going to be local here, and then you can't share with the person who is next to you, and you need to go to a different frequency, a different channel, and what we were seeing, and that was the result of the analysis we conducted, is that it's inefficient. So it would be a pity to waste a resource that is so important with inefficient approaches. So we have to balance both aspects.
Klaus?
Yes, I think when we come up to Subterra, there I am more sort of open and see that we need new schemes, because that is very local, and I think we will need to have new technologies in order to cope with it. Is just the line of sight in order to cope for that. Signal will be blocked by objects. So we might need new schemes, and then I think also new licensing methodologies in that at least to consider. But nonetheless, regardless if new or existing, what is important for us as operators is that we get them well in advance in time.
Yep.
Because that has been a little bit of an issue, I think, lessons learned from 5G, that we have seen that some allocations have been dragging out of time for various reasons, and the spectrum auctions has been used for various other initiatives in countries, delaying the process. So whatever we do, if I may say, it's important that we have a lot of time in order to prepare ourselves as an industry.
Time, important. We need to start now, essentially.
Yeah.
Pressure again. So just stepping back a second, that idea of local licensing, is that going to be, does that mean we're going to have different kinds of organizations involved in that licensing beyond the traditional operators? Is that where private network, industry, enterprise is going to end up? I'm floating the question right there across the panel, because I could see that applying.
Yeah. I will start, and that's exactly the assessment we did for spectrum set-asides. We started an assessment with private networks, spectrum for private networks, but we realized it's much bigger than that. It's shared access, and it's local licensing as well. And what we're finding is that it becomes inefficient. But also we have a different conundrum. So when we are discussing in the ITU what a mobile service will look like in the next generation, IMT 2020, IMT 2030. There's a number of characteristics that we need to provide. Download, upload, latency, whatever. And then when we translate that into spectrum, we say we need X amount of spectrum. When that amount of spectrum is start becoming put aside for whatever purpose, it means that the mobile operators are actually not getting the spectrum that they need to provide the service in spectrum that was identified for that purpose in a harmonized manner. I do understand there's more pressure on spectrum, but it's really difficult when part of that spectrum that could be used for the society, for the benefit of everyone, for the benefit of billions, you start putting it into specific hands, and then the use becomes inefficient.
We launched in the UK actually in 2019 a shared access framework in a bit of spectrum where we knew there was a nascent mobile ecosystem, the 38242 gigahertz band, so just above the spectrum that was awarded to MNO for a public network. And we have seen quite a significant take-up and quite a number of new entrants. Not only, to be honest, the MNOs are using some of this spectrum for localized private networks, factories, plants, warehouses, logistic hubs, or ports. The UK being an island, we've got a lot of ports. But we've seen other companies coming in and starting to deploy infrastructure using that bit of spectrum. We've got more, only in this band, we've got more than 1,000 licenses. And the number, whilst it started relatively low, in the last year has really increased quite significantly. So we think there is demand for that type of model. It has enabled several different players to actually enter the UK market and deliver something different. And actually, in response to your question, I've always believed, and we believe, that there is a sort of multitude of networks, starting from your private network within the factory to your public network. It's a little bit of horses for courses. What do you need to provide? Clearly, there is a massive, as Luciano was saying, massive benefit in the provision of public network to consumers across the country, but there are also very specialized needs that in many cases are better met by private networks.
I guess the question, I'm going to put this to Ari actually, is you talked about the consistency, how important it was to have that consistent experience. And I'm looking at this and thinking, if we have local licensing for some of these key new capacity bands, whether it's the 7 to 15-ish gigahertz range or whether it's the terahertz, doesn't that mean that the experience that users have on that macro network could be very variable? It could be incredibly good if you happen to be in a location where your operator has that license for the terahertz, and in another location, someone else has that license and you haven't got the experience. Isn't that going to make the experience very inconsistent?
Yeah, that's definitely a big challenge, and I would not like to go that way with the golden band. I mean, like Klaas said, the sub-terahertz and the kind of private networks, fine. They are contained in a building.
Yeah.
Then it's okay. But then when you really want to build something we are used to since the 2G days, that it's the same all over the place. It doesn't work.
So you're thinking there might be, rather than a private network license for a location, it might be an indoor license, is what you're thinking almost. Because you've got terahertz, it's probably fairly easy to contain it.
Yeah, for those bands, yes, but not for the kind of macro band of the 6G, which is the 7 to 15.
Yeah.
Because they will filter out of the building.
Yeah, there we would. We are used to build the network so that it would be one license across the network, same performance. So that's hard to break.
So competing demands.
Yeah.
High consistency, but different people wanting that capacity.
And then if I may add also that as we see, there are quite a lot of new demands coming into communications. It is so vital for the industries, for people, in terms of cybersecurity, just to mention one. So when it comes to the macro network, where it has a big impact, big coverage and so on, I think there we need to, there we also see a trend that our customers rely on credible players that have the ability to operate mechanism and abilities in order to secure the sustainability of it. So that, I think, also drives towards to have macro allocations, not of course excluding to have specifics indoor or at minor places.
To answer this question, we're talking about what will happen in the future for the sharing, spectrum sharing. But I would like to take back to what's happening right now. What's the fact today? So we have this, for example, the local license already in some nations, and they also have some pioneer, for example, for the early birds, some early small-scale deployment. But on the other hand, the mobile operators using their public spectrum, they are deploying logic private network also. So as I know, worldwide, there's already there are more than 10,000 use cases, applications for the operator to extend their business based on their infrastructure to be market. So I think maybe we can. It takes time for us to further to understand what will happen in these two directions. It was to try, but right now today we have to see the fact is the mobile operators private network is more professional, and the business developing is better than just a pure private network. That's
Yeah, one thing that we realized working with our operators is that there is a perception, and we don't know where the perception comes from, is that spectrum for private networks needs to be set aside, and for local licensing needs to be set aside. And operators are not providers of solution. Mobile operators have been providers of solutions since the first generation, and they're able to provide private networks as well, and they're able to provide all these services. And it's something that at the GSMA we're taking very seriously to show that this is happening. We're actually going to be publishing quite a lot of material on that this year. Of course, we understand there might be demand in some cases for additional local license, additional spectrum for private networks, but I think needs to be considered really carefully so we don't get into the inefficient bit.
So I have a slightly different question. So we have these new use cases like XR coming through, or very high quality video that's being live streamed, and there's three-dimensional video and very low latency. There's a whole load of different things, probably things that we haven't even thought of yet, is what typically happens with these technologies. The market from a technology perspective is more complex. It used to be a device connected to one frequency band at a time, and it was relatively simple to work out what was happening. With 4.5G or Advanced Pro, devices were connecting to multiple frequency bands at once, but at least they were all on 4G. With NSA, they're connecting to NR and 4G at the same time on multiple frequency bands. And you can see the number of frequency bands, the number of types of spectrum is multiplying. It's getting more and more complex. And the applications are getting more varied. It used to be we made phone calls, then we made phone calls and sent text messages, but the text messages were 160 characters, and that was it. Then we started browsing the web, then we started tethering our laptops, then we started doing YouTube and TikTok and Spotify and cloud gaming, and there's all these other things coming through around smart glasses that tether to your phone, which you walk around in the street, or industrial automation, or smart agriculture, or automotive applications. And all of these devices are connecting to multiple frequency bands on this wide range, with 6G from terahertz potentially down to UHF around 500 megahertz. Massive range. So if we were here in 10 years' time and 6G's out there, how would we measure our success? How would we know that we'd done the right thing, it was all working right? How could we understand that world in 10 years' time to know whether these applications, these wide varying things, are working correctly? How should we think about this? Throw that to the panel.
I may say it's all about the consumers. If in reality all of this complexity that will evolve in the next 10 years results in consumer having the best of services, that is the success. Whatever that is, whatever interface you're using to actually access the services you want, that is the success factor.
Plus the enterprise.
Sorry?
Plus the enterprise sector also
Yes.
getting the benefit of it.
Yes.
So how would you measure success for an enterprise?
More and more enterprise use cases being with over the mobile, now first 5G and then 6G.
So is that less fiber usage, or is
Yes,
it
less fiber usage, less Wi-Fi, more of 3GPP.
I would just shortly add that we have a working market in the segments where consumers or business buy, that there are one or two or three, not one, but two or three or four actors in the market. So that there are markets that drive out whatever consumers or businesses want to buy.
So there's competition,
There is a competition.
and it works seamlessly,
Fashion, yeah.
and we don't get complaints, and the enterprise and consumers are happy. It's quite a big juggling act, isn't it?
Well, I'll use a GSMA catchphrase that we had before, that we have connected everyone and everything to a better future.
That's a good one.
Like that.
Last thoughts from the panel. We have a little bit of time left, just a little bit. What have we missed? What are the other things that we should be talking about? I mean, machine learning. I mean, I've seen some interesting pieces around how 6G is being designed with machine learning. I've seen the sensing. We haven't talked about the sensing piece.
Yeah,
The sensing piece is something which probably isn't so widely known. What does that tell us? How does that apply to the spectrum piece?
We can identify objects, people moving with the sensing, and it's really a platform enabling so many things I can't even start to imagine. There will be lots of new use cases with it. And then AI indeed will be more and more inbuilt, even to the air interface. We will do AI-based air interface for 6G.
Marvin?
Yeah, so in my opinion, so we can learn from NB-IoT is one of the try of our industry to try to, based on same band, to bury different, to offload different kind of use cases. Technically, it's just we take some piece of spectrum to allocate it to some specified applications. But one time, single band implementation of the network, but we can have multi applications. And furthermore, for the sensing technology and also passive IoT, we are using similar approach, technical approach, to try to we can see just divide some slicing like spectrum slicing or time slot slicing to then we can support different, technically can support different kind of applications just based on this 5G network. So I think this direction is, the industry is now working. Technically, we support different applications based on same band, one-time deployment, unified 5G network.
So I'm going to thank the panel. So I think you've heard use cases for 6G. You've heard, I think, that there's an expectation as we move past COVID that data volume is going to go right up. There are some new demands around XR, around high consistency all of the time in all of the locations people operate. There are enterprises. There is interest in the very high frequency capacity bands for capacity, but also ubiquitous low coverage bands. And there are new models around extending the shared licensing approach that's been used in a few places in the world already. And there's also interest in local licensing. But there's that tension on local licensing about how do you maintain the ubiquitous experience, and then how do you measure that and make sure it's a great experience for everyone, consumer and enterprise. So thank you very much.